Biomedical waste management is a critical discipline within healthcare that ensures the safe handling and disposal of hazardous materials. This presentation focuses on the rigorous standards required to protect public health and the environment from the risks associated with medical waste. We will explore the systematic approaches used to manage these materials from the point of generation to final disposal. By understanding these protocols, healthcare facilities can maintain compliance with stringent legal regulations while ensuring the safety of their staff, patients, and the surrounding community. Effective management is not just a logistical necessity, but a fundamental pillar of modern medical ethics and environmental responsibility. Supply chain, barcoding, and GPS tracking represents the fifth major module in our study of biomedical waste management. This specific section focuses on the technological integration required to oversee the movement of waste materials across various geographical points. We will examine how supply chain logistics are enhanced through digital identification tools like barcoding, and how real-time monitoring via GPS tracking provides a fail-safe against mismanagement. These three components work in tandem to create a transparent and highly efficient system that minimizes human error and maximizes accountability throughout the entire life cycle of hazardous medical waste. Digital chain of custody is the foundational concept of Lesson 5.1, emphasizing that modern biomedical waste management relies on tracking hazardous materials from the hospital ward all the way to the destruction plant. This means every individual bag of waste is monitored as it moves through various hands. Furthermore, this system creates an unbroken, auditable trail of environmental compliance. By maintaining this digital record, facilities can provide proof to regulatory bodies that every gram of waste was handled according to the law, ensuring that there are no gaps in the history of the waste journey from creation to total elimination. Barcoding mandates are a legal requirement discussed in Lesson 5.2, where the Central Pollution Control Board, or CPCB, requires barcode or QR code labels on all outgoing waste bags. This is not optional. It is a strict regulatory standard for all healthcare facilities. These labels serve a vital function, as they capture the generating department, date, time, and color category of the waste. By scanning these codes, a digital log is instantly created that identifies exactly where the waste came from, when it was sealed, and what type of hazardous material it contains, such as infectious or sharps waste. Departmental accountability is explored in Lesson 5.3, highlighting how barcodes trace segregation failures back to specific surgical teams or ICUs. If a needle is found in a yellow bag where it doesn't belong, the barcode tells the administrator exactly which department made the mistake. This precision allows administrators to implement targeted retraining rather than generalized reprimands. Instead of lecturing the entire hospital staff on waste protocols, management can provide specific, constructive education to the exact team that struggled with segregation, leading to much more effective behavioral changes and improved safety outcomes across the facility. Preventing illicit diversion is the focus of Lesson 5.4, which explains how digital tracking mathematically eliminates the theft of unsterilized medical plastics. Because every bag is weighed and logged at the hospital and again at the treatment plant, any discrepancy is immediately flagged. This rigorous accounting effectively dismantles the dangerous black market for recycled, contaminated medical goods. By ensuring that plastic syringes or tubing cannot be siphoned off for illegal cleaning and resale, the system protects the general public from the catastrophic health risks associated with using scavenged and contaminated medical equipment. GPS fleet tracking is detailed in Lesson 5.5, stating that transport vehicles must be equipped with real-time GPS monitors. This technology allows central authorities to see exactly where a waste truck is at any given moment during its transit. This oversight ensures adherence to approved routes and completely prevents illegal dumping in unauthorized areas. If a driver deviates from the path to the treatment facility or stops for an extended period in an unusual location, alerts are triggered. This level of surveillance guarantees that hazardous waste never ends up in a landfill or a local waterway. Centralized tracking portals are discussed in Lesson 5.6, where facilities upload daily generation metrics to state and central digital dashboards. This real-time data entry ensures that the government has an accurate picture of waste volumes across the country. This infrastructure is crucial for dynamic resource allocation during biological crises, such as the COVID-19 pandemic. During such events, waste volumes can skyrocket, and these portals allow authorities to redirect transport and treatment resources to the areas under the most pressure, preventing the healthcare system from becoming overwhelmed by its own hazardous output. Packaging integrity is the subject of Lesson 5.7, mandating that bags must be strictly leak-proof and sharps containers must be tamper-proof. These physical barriers are the first line of defense against infection. If a bag punctures or a container opens during transit, the tracking systems become irrelevant because the hazard is already loose. Additionally, all containers must feature universal, highly visible biohazard symbols. These symbols provide an immediate visual warning to anyone handling the waste, ensuring that even without a scanner, the dangerous nature of the contents is recognized and respected by all personnel involved in the supply chain. No secondary handling is the final operational rule in Lesson 5.8, requiring that waste must go directly from the hospital to the treatment plant. There are no intermediate stops where waste is moved from one vehicle to another or stored in unsecured secondary locations. Furthermore, prohibiting manual resorting drastically lowers occupational exposure for sanitation workers. By ensuring that nobody has to open a bag or touch the waste once it is sealed at the hospital, the risk of needle sticks or exposure to pathogens is nearly eliminated, protecting the health of the workers who manage our waste. Thank you for completing this detailed lesson on supply chain, barcoding, and GPS tracking within the framework of biomedical waste management. We have covered how digital tools and strict physical protocols work together to create a safe, transparent, and accountable system. By adhering to these barcoding mandates and tracking requirements, healthcare professionals play a vital role in preventing environmental contamination and protecting public health. Please ensure you review these protocols regularly to maintain the highest standards of safety and compliance in your daily operations. This concludes our session on the technological safeguards of medical waste disposal.